Okay, WebAssembly by itself is a specification of a virtual machine for running some bytecode, but by design is secure, so it cannot go in if you don't want it, and cannot go out if you don't want it. So it's completely secured, it's completely isolated, it's portable, so you can run WebAssembly stuff in browser, in your PC, in your Mac, and also in a mobile application. It's absolutely language independent. The main use of WebAssembly at this time is to run stuff in a web browser, but we'll see that is not the only application. Okay, who am I? I'm Marco de Nittis. I'm a little bit an outsider because I'm not exactly an app developer. I'm focused more on web, more on service, more on backend and something like that. But I love several arguments that are sometimes related to this kind, for example, AI and WebAssembly. And I like to play a lot with everything that I can thinking about, so that's good. Okay. What we're talking about? We talk about WebAssembly and how WebAssembly could be related, useful for an app developer. How does it live with the Swift ecosystem? So we'll check first what is WebAssembly, really, and how WebAssembly could work well with Swift, either to do web. So web front-end, as we'll see, and not only web. And finally, we'll check if this kind of stuff could fit in a mobile application. So, before we start, how many of you already knows WebAssembly? Please. Okay, it's a new argument. So, okay. WebAssembly by itself is a specification of a virtual machine for running some bytecode, but by design is this machine, this runtime is secure, so it's a black box, it's a sandbox, sorry, that cannot go in if you don't want it, and cannot go out if you don't want it. So it's completely secured, it's completely isolated, it's portable, so you can run WebAssembly stuff in browser, in your PC, in your Mac, and also in a mobile application. It's absolutely language independent, so you can write something that you can use as WebAssembly in, I can't say in every language, but in a lot of languages. Swift also. The main use of WebAssembly at this time is to run stuff in a web browser, but we'll see that is not the only application. So, is portable, is independent from the platform. You can run it everywhere. It seems like some kind of old friends applet Java. No. That's not Java, that's not an applet, it's completely different things. It born in a completely different way, secure at first, so it's lightweight, so it's completely different. Why use WebAssembly? Because it's sexy now. Not really. Why WebAssembly? Because you can write a WebAssembly module in the language that you prefer. You can, thinking about web, maybe it's not your main focus, but it's good to know. You can create isomorphic web application. What does it mean, isomorphic? It means that you have the same language on the front end and also on the back end, so you can share your code between the two parts. It's very useful sometimes. the main way to work with to create an isomorphic application is to use JavaScript, because you can use JavaScript on the front end, of course, but you can use also in the backend with Node.js or something like that. But with WebAssembly, you can do it with every language you want. You can do it with Swift, you can do it with Rust, you can do it with .NET as you want. So it's a great leap forward if you want to share resources and also competencies before front-end and back-end team, and also for mobile team in this way. It's ubiquitous, as we already said. You can run it everywhere. It's highly composable and versatile because a WebAssembly, when you write something and you build it in WebAssembly, you package it in a file, WASM file, and this file could be connected to your runtime, to your application, and also you could share everything you need to this module, so it can use it to be compose functionalities independently by the language. It's secure. As I said, WebAssembly is born with security in mind. So it's completely sandboxed. It's completed. You cannot access anything if you don't express that you won't do it. And also WebAssembly in this specific moment is growing exponentially, because every month it's gaining a lot of capability to improve its performance, interoperability, and so on. For example, SIMD, if you don't know what is it, is I can say it's a kind of processing instruction that let to work with several data in the same time, so to improve the performance of some kind of calculation a lot. Actually, there are some extensions of WebAssembly that permit the use of SIMD instruction in WebAssembly, so boosting its performance for some applications. How you can work with WebAssembly? WebAssembly is independent by the language, so you can write WebAssembly module in every language that supports as a target WebAssembly, and there are a lot. C, C++, Rust, Zig also are now, I can say, the first class languages for WebAssembly, but there are a wider support with Swift, .NET, Go, and name one, you can do it. To create a WebAssembly module, you need to compile, so it's easier to create WebAssembly using a compiled language. You can do it also with Python, for example, but there are some gotcha, and so it's not so easy. Every module you create with every language you want, it's portable, and you can use it, you can swap it with some limitation with everyone, so every other one. So it's like kind of Lego blocks, Lego bricks that you can use it to build your application. We talk about the front end, the web browser in this case. Actually, this is the screenshot of the use of WebAssembly. WebAssembly is supported by almost all modern browser. There are some gotcha with the mobile browser, but you can do it. You can use it almost everywhere. When you work with WebAssembly to build a web application, you have to know that WebAssembly is a sandbox. It's completely deaf, dumb, and blind. It cannot interact in any way with the browser. Oh, how can you use it that? You can use a JavaScript glue to export browser functionality feature to your WebAssembly module, and to receive event function generated by the WebAssembly module. So JavaScript is a kind of middleware to let expose to your WebAssembly module the functionality, the feature you need about the web browser. So if you want to interact with the DOM, so with the web page, there should be a JavaScript piece that give the functionality to your WebAssembly module. Your WebAssembly module should use this functionality in order to interact with the DOM. Also, if you want to do some kind of HTTP connections, maybe to some kind of backend, you cannot do it directly. You have to pass with it, to work with JavaScript to make this kind of interaction. This sounds a bit weird, but don't worry, you don't have to do by yourself. There are a lot of library and tools already made, ready to use to do that. If you want to use Swift to work with, for instance, to create a module for the web browser, there is a great project, SwiftUI, that give you everything you need to let interact your Swift code with a web page, so with the browser. You don't have to do anything except write your Swift code. So SwiftUI bring you some kind of tooling in order to create project already prepared to be bundled, to be built, to be distributed to the web. So you have, for example, for JSKit, JSKit maps, it's a library that maps all the browser functionality to WASM, to Swift, sorry. So you don't have to bother, could I do some kind of HTTP connection? Okay, use a function JSKit, let's do it for you. And also, SwiftUI bring you a bundler that's Cartoon, that let you build hot rebuild while you are developing the code. So it's very easy to have a very comfortable developer experience to work with it. And also there is a WASM pad. WASM pad is check it. WASM pad is a kind of playground that you run in the browser, and you can write directly your Swift code, run, and let it see directly in the browser. So it's very easy to do some sketching, play, and something like that, without leaving your browser. Okay, but I want to use Swift to do something in the web. What could I do? There are mainly two scenarios. They are completely different. The first scenario is that you want to build a completely application in Swift and you want to run it on the browser. So no JavaScript, no other things, only Swift, because I love Swift. In this way, you can do it everything by hand, but it's a huge work. Maybe it's useful to have some kind of a framework, a web Swift framework that give you all the stuff for you, and you have also only add your application code, not only wiring, all the architecture and so on. So all your web application will be Swift and CSS, of course, if you want to do some kind of styling. The other completely different scenario is you have a web application already in JavaScript, React, whatever you want, but you want to integrate some kind of Swift feature. Maybe you have a mobile application that has some kind of algorithm that I don't know what does, built in Swift, but I want to use it in a web application. You can do that because you can extract only the functionality that you need. You build it in a WebAssembly module, and you can let your JavaScript frontend interact with this module directly in the browser. So it's you use WebAssembly only to pack some functionality, some vertical feature, and integrate it with your already existing maybe web application, or with the application that is built but is built by a front-end team of your company. So the second scenario is useful for specific tasks. If you want to build a completely web application with Swift, what could I use? Bad news, for Swift there is no such kind of a rich ecosystem from this point of view. There is Tokamak. Tokamak is a great library, a great framework that lets you build a web application using the approach of SwiftUI. The problem is that actually is not very actively developed, so it's great, but you have to think twice if you want it to build an application that will last. If you do some kind of prototype, that's great, but think about it. Or if you want, you can start to contribute and let go on. A good thing about Tokamak that could be integrated with Vapor, doing SSR. What is SSR? Server-side rendering. So you could render your application, your page, on the first request directly in the web browser, in the server. So the browser already received the HTML of the page, and after Tokamak takes control and let you use it a single-page application. So with WebAssembly, we do it everything in the browser. It's a great solution to have application site that should be, for example, SEO-friendly. There are alternatives, not WebAssembly oriented, that is SwiftUI, that that also let you use SwiftUI, but not render on the browser with the WebAssembly, but render on the backend. Let's try it. Okay. Here, you see? Okay. We have a Swift application written with SwiftUI, or almost SwiftUI. If you already know, if you know SwiftUI, you know more than me. So there is a very simple increment-decrement application. If I want to run it, oh yeah.
It's command plus and like a browser it will.
This is better? Okay, thank you. Cartoon is the Swift WASM bundler, so it does it everyday heavy lifting, so building, bundling, putting in a web page, creating all the JavaScript that you need to make it. Okay. Okay. That's my beautiful web application. You can increment, decrement. You can interact also with other functionality of JavaScript, maybe the alert way. We could write directly in the console, so it's useful sometimes for debugging. And the good thing, if you decrement, please, if you want to be kindful. And it's okay. Cartoon also automatically rebuild and push your modification to the browser. So it's very fast interaction cycle. So that's great, and will continue to work. Here, some kind of interesting thing is the JavaScript kit that we already mentioned, that let you interact with, for example, alert, with all the JavaScript functionality, and also the print functionality. Instead of writing in the log of the application, writes in the log of your browser. So you can use it to interact in a very fast way with your browser and with your code. Let's talk about performance. Often we hear about WebAssembly is about performance because it's more performant than JavaScript and so on. Is really more performant than JavaScript? Well, maybe, sometimes, it depends. Here there is some benchmark about web application, web front-end. The blue square represents some WebAssembly frameworks. So in the first column there is the vanilla JavaScript, so the JavaScript only, and this is the base point. We see that it's not so fast. Maybe React, okay, it's in the last position, but we have also other WebAssembly more slower, because maybe sometimes WebAssembly is more performant, but it depends on the application, what's the use you do it, depends on the language you write WebAssembly with, because if you write WebAssembly with .NET, the last column are for Blazor. Blazor is a WebAssembly framework for .NET. It's very slower because the .NET WebAssembly version brings with WebAssembly all the .NET runtime. So you don't have only your code, but you have only the .NET garbage collection and so on runtime that slow a lot. Maybe with Swift or Rust that's not true because they don't have a runtime, but it depends. And also, if you want to do web stuff, you have to also interact with the DOM, the document object model of the page, that is not so fast. So maybe this kind of benchmark does not show the real performance of WebAssembly, because you have also the point about the DOM interaction. So if you want to use WebAssembly to be fast, it's not maybe could help you, maybe not. You have to check. If you don't want to work with the browser, is WebAssembly useful? Today, the answer is yes. The web part of WebAssembly, it's only because it is born with the web standard, but it could be used also outside the web. You could use it with command line, you can use it with your application. There are a lot of scenario here. Solomon Hykes, if you don't work with DevOps, you don't know it maybe, but Solomon Hykes is who built Docker. Docker is the and container approach is actually what will bring all the modern DevOps practices. So he says if WebAssembly and WASI, and we'll see what is WASI, existed 15 years ago, I should not build Docker, because they give you enough stuff to do that I want to reach with Docker. Why? How? If you want to run a WebAssembly module in the backend, for a backend I mean everything that is not a browser, you need a runtime, because WebAssembly does not run itself. It needs a runtime to run this module. It's anyway sandboxed, so there is not networking, not file access, nothing about that, and it's not so useful in this way. But WASI is a new specification, it has 3 years now, or more maybe, was in the rescue, because it let standardize all the features that are needed outside the browser, maybe file access, access to some kind of API that maybe could be similar to the POSIX standard. So if you jump in the WASI wagon, you can use maybe the access of file system if who runs your WASM module permit it, because anyway the sandbox limitation is already here. There are several runtimes that you could run, for example, in the command line, WASM or WASM time, that let you run your WASM module as a program. You can also, using embedding this kind of runtime in your application, you could integrate your application with WebAssembly, exposing or interacting with the function that this WebAssembly module exposes. There are also other way to interact to use WebAssembly. You could work it with container. There are several container runtime based runtime that you could run directly WebAssembly module. You could use it in Kubernetes if you know it. Is it possible? There are several solutions to use WebAssembly for serverless computing, because one of the great things about the WebAssembly is that it is an incredibly fast startup time. So you can spin up a WebAssembly function in milliseconds, not second. So it's very friendly from this kind of workload. It's very lightweight. It's incredible. So there are several cloud solutions that already arise about WebAssembly. For me, on WASM Cloud are, for example, two of the most famous services about that. There is also a Swift Cloud, vertical for Swift, that let you write some backend codes, some function in Swift that could be run in a serverless way. So it's very interesting. Another kind of approach in which WebAssembly is very useful is the plugins feature. It's very easy to create a plugin system with WebAssembly. Maybe your application runs in Swift, in a mobile application, whatever you want, but you have some kind of way to extend your application. You can use it with WASM, WebAssembly, so you let your user, developer, I don't know, write some functionality that integrates with your application in WebAssembly and plug in hot in your application. So put out without restarting web application. There is several already applications that do that as Envoy, ZLJ, that Envoy is a kind of reverse proxy. It's a bit limiting inside it's a web proxy, but that let you write extension and plugin with WebAssembly. Interesting, Exitism is a framework to write plugin, to write and use plugin with WebAssembly. So SED actually doesn't have Swift binding, but it's still increasing. So maybe in the future we'll have. Another interesting scenario of use of WebAssembly are the blockchain smart contract. Blockchain smart contracts are programs that run within the blockchain, inside the blockchain. So it's actually is used very often with WebAssembly to let the user create smart contract. Let's try it. Okay. Here I have a code project in which I create a very complex feature, Fibonacci number generator. So I create a function that calculates Fibonacci in Swift. I can use this function maybe from a Node application, so from JavaScript. Here I have a great sample that will load the WASM module that we will create using Swift, and with some kind of JavaScript magic code that we don't care about, load it in memory and run it. Okay. Here we'll build our application, and if you want to actually we call JavaScript call your Fibonacci function and receive the result. Here we do some kind of performance check, very raw, and we see that the Swift WASM Fibonacci implementation is lower than the JavaScript one. Could happen. The funny thing, if you do the same, not writing the application, the function with Swift, but for instance, with Rust has better, the WASM module created by Rust has better performance. Maybe we can build it, the Swift, without the bug symbol and so on, will be faster. That's okay. It's not, I don't want to demonstrate that it's faster or slower. But interesting that you have to check. The last interesting point is, but could I do that in a mobile application? Could I use WebAssembly to add some kind of other modules, other functionality in an existing Swift native application? Yes. Yes. There are 2 or 3 solutions. The most used is the WASM3 library. WASM3 library is a C library that you could embed in your iOS project. WASM3 is not a just-in-time compiler, but it interprets the WASM code and run it. You run it very fast for an interpreter. You have to do this kind of approach because there are some kind of limitation from Apple for generated code inside a mobile device. So you cannot run code that you build inside a mobile device. The just-in-time compilation means that you'll create some kind of instruction that iOS should run, the processor should run. You cannot do that. Or better, there are limitations. You have to be entitled by Apple to do that. So normally the interpreter approach is more suitable. So you can do that. Let's check. I have. Okay. Here I have an iOS application in which from the Swift code I load my Fibo1 WASM module that is bundled inside the application. I'll open it, I'll load in memory, and you can use it, the Fibonacci function that we already seen. Okay, you cannot see that, but there is some kind of log about Fibonacci. The load WASM Fibonacci are in C in this moment, but you can write it also in Swift. Because there are all the wiring to the WASM3 library that is bundled. Maybe you can see. You can see that. Maybe you can see that in the source, so you have to embed it directly in your application. So it could be used. So in this way, you can download the WASM module also maybe from the network and run it. But you have to, of course, pay attention to a lot of things doing this way. But you can do it. You can extend your application, or you can add plugins functionality in this way. So there are some kind of scenario that could be useful. Also, you can use the same WebAssembly module in maybe for an Android application. So if your application is built natively in iOS with Swift, natively in Android with Kotlin, but they will share some kind of logic, maybe share also with the backend or with other kind of stuff with the front-end web. You can do it with WebAssembly and distribute to all the target and can use it seamlessly. So that's nice. Okay. WebAssembly could be interesting. It's for my point of view, it's a great potential in this way because you can use it everywhere in a very fast and efficient way. Actually, it has a great evolution. There are a lot of things that are happening in the WebAssembly ecosystem, new feature, new functionality. Still, this is young and not so mature, I can say, because it's evolving. It's evolving, and maybe in the next 2, 5, 10 years will be a great fundamental stuff to work with. It still also some kind of very important parts, maybe networking. Okay, you can put it, but there is no standard way in this, or better, they are standardizing the way that you can use networking from different kind of WebAssembly useful. Another not so good point is not easy to debug because we have another object in another format, in another language that is embedded in your application. You can do that, but it's not so easy. So, thank you very much for the attention. The code that we'll see will be available to the GitHub. You'll see with the slide. Also, we have with some friend a Telegram channel to share WebAssembly stuff. If you want to join, you are welcome. Thank you very much.